So for this question, they give us this information and then they ask us to find the derivative of the inverse function evaluated at a. And to use this, we are going to use one of the coolest theorems that we have in Calc 1, and that is that if you're trying to find the derivative of the inverse, so that would be f inverse and then the derivative. So the derivative of the inverse is going to be 1 over f prime. Now here's how I think about this theorem. I think about like when I have a fraction, when something goes in the denominator, it flips. So I think about this inverse derivative, that notation is going to flip. So it was negative and then the prime. So when I put it in the denominator, it's going to be the prime and then the negative 1. So it'll be f prime of f inverse of x. Okay? Now, please note, like this theorem is so amazing because what it allows us to do is find the derivative of the inverse without actually calculating that derivative. Because what we can do is we can evaluate inside of these parentheses first. So for this particular question, we're looking at an a value of 0. So what I would first start off is I would replace all these x's with the a is equal to 0. So we have f inverse's derivative of 0 is equal to 1 over f prime of f inverse of 0. So that's specific to our problem. And then I would say, okay, how do I find f inverse of 0? Well, they give us information about f of pi is equal to 0. Now, remember that the inverse and the function, they undo each other. So if I take the inverse of the left-hand side and I take the inverse of the right-hand side, I have preserved that equation, but I get a new equation in the second line here because the inverse and the function will undo, so that will just leave us with pi on the left-hand side, and that will be equal to f inverse of 0. So from this f of pi is equal to 0 condition, we are able to say that our f inverse of 0 is equal to pi. So what I'm going to do is I'm going to plug that in for f inverse of 0. I'm going to say that that is pi. All right, so that's a little side step that we take to figure out our f inverse of 0. Now, at that point, we just have to find f prime of pi. And again, they give you that information. They say f prime of pi is equal to negative 1. So you have 1 over negative 1, so you get negative 1. So that is our inverse function's derivative evaluated at 0. So that is the rate of change of our inverse function at x is equal to 0 is negative 1. And this is such an important theorem because a lot of times out there in the real world, you have data about like what the function is evaluated at a point, what the rate of change is evaluated at that point, and you can use that information to figure this out without ever actually having to compute the inverse function and then taking the derivative. So that's the background for all of these questions that we're about to do on 290 through 294. And I really want you to realize the importance of it is out there in the real world. Sometimes you're going to have this data and you're going to be interested in how your inverse function's rate of change is. And we can do that without actually finding the inverse function as a function and differentiating. We can use this theorem.